Hey guys, welcome back to another video. This one's not actually going to be about my car. It is, however, going to be about turbo manifolds. So I have a project where I'm making a manifold for a customer, but it's a bit of an irregular request. So this is going to be an interesting one. I actually sent the manifold out. It's already finished while I'm filming this, but I sent it out before I remembered to film an intro. So that's why I'm standing next to the Laurel, but I hope you enjoy. Yeah, drop any comments in the comment section and we'll get into it. So this isn't for my Laurel or my Corolla. This is a customer turbo manifold to suit a 2JZ GE in a Mark IV Supra. So in this video, I'm going to show the process of finding the turbo position, making a jig, designing the manifold, most of the process that goes into this. So this is a bit of a special one as well, where I used a sheet metal jig that was made by the customer and his friends, and they sent that up to me, and I've had to work around that to replicate the engine bay because I don't have the car in the shop here. So it's a bit funky, a bit different to what I'm used to doing here, but I'm very happy with the outcome, and I hope you enjoy the process along the way. Now the next step is to assemble this puzzle that the boys over at Voxel Engineering have put together for us. So we had them 3D scan a Mark IV Supra engine bay with the engine in and create this jig setup. So this will bolt to the underside here, and then all of these puzzle pieces click together to replicate the strut tower and the accessories on the engine and give us clearances for the engine bay, so that we can now make a manifold to suit this customer's exact application without even needing the car here. Jig assembly is all put together. Looks very complex, but really it just does the job of replicating the clearances in the engine bay, such as the chassis rail down here, obviously the strut towers up here, objects on the side of the cylinder head at the front of the engine, and engine mount stuff. So we have all of our clearances in place now. I can hang a turbo in here and a collector, start making jig that bolts from here to the turbo position to hold that in place. That'll be the next step. And then we can start making all the runners from the head flange into the collector and mocking up wastegate and whatnot. So I have this old GT35 Garrett turbo that I've borrowed just to mock this up. That's not the turbo that will be going on this manifold, but it's around a similar size, so I'll be using that for mock-up. And I ended up using the hoist arm with some ratchet straps to hold the turbo in position, as that can go up and down, and obviously so can the ratchet straps. And then I've used the welding bench, which has caster wheels on it, to be able to move our engine bay around the turbo and get it in position where it has enough space to clear the strut tower and the chassis rail. And I have grabbed a few little bends to sit them in place and make sure everything's going to clear. So I'm very happy with this turbo position now, and we can start making the jig. now we have it. The jig is all welded up. It's not really anything too special to look at. It's just some mild steel, round bar. Things are machined. I like to have these flanges bolt through the center, as you can see, so that I can switch between like a T3 bolted flange and then put a V-band flange on it. So the same jig will work with multiple different turbo flange setups. But now I'll pull this off, cut these little pieces of round bar away, which were just there to hold that collector in place while I made this. And yeah, once this is gone, I can put that collector back on and start making runners. So when I'm designing a new manifold like this, I'd like to start with the shortest runners because one, they're the easiest, and two, this runner here, say for example cylinder number 2 down to the collector, that's then going to need to be avoided when making the other runners. So if I was to make cylinder number 1 and cut it across like this and then have it come up into here, and then that bends in the way, when I go to then make the next runner, the bend won't fit on the collector. So you need to be mindful of how things fit with each other. So I'll make this first one, and then cylinder 1 can work around that, and then everything else can slowly populate the area. So we have different radius bends. There's small, medium, and there's a large as well with an even larger radius. The medium and the large also come with an option with a leg on each side, which is really handy for joining straight sections. Rather than having, say, 2 welds, you can have 2 of these straights with 1 weld in between. So you want to be as economical as possible. So that'll give you, that's 90 mil of straight because there's 45 mil of leg on each. So if you do that, obviously you can save yourself putting a 90 mil straight in there, save yourself all the prep of an extra weld, all the welding time, all the gas that goes into it. So being economical is very important as well. So these are really handy to have around. But obviously things like this, we're going to want to go like a real tight bend on there to try and get this back up without swinging the bend all the way into the flange before you even get to do the reverse. So tight there, probably a medium on the flange there, and then a bit of a bridging in between. This is just a bit of scrap that I had in the bin, and you can see already that that's pretty close. We'll be able to make something work with, and we'll cut another one of these that has a bit more angle on it and get it into the right place. So now I've gone and cut a new one of these medium radius bends with the leg on it. It's has a bit more bend with a bit of extra length on it to try and bridge that gap. So that'll be the small on the bottom, and then the medium on the head flange. And as you can see, pretty damn close to having that finished. So that's one runner done. Once I've prepped this and tacked it all together, I can tack it into the jig, and then I can start making the other runners around it. And then eventually we'll have all of them done. So now that the jig setup has come away, now that I know that I've got enough space to work around where I'm going to route these runners, makes it a lot easier obviously. I can show you how easy it can be sometimes. Like I grabbed this out of the scrap bin, this out of the scrap bin, and a bit of straight that I had lying around. This is just a small 90. Once you put all these together, we're like nearly at the point of having a runner straight away. So this will come off the head, and then these two will connect us down onto the collector. So you can see that top bend needs to be a little longer with a little extra angle in it. But like, man, that is nearly perfect. I'll cut a new one of these for the top with a bit more length, a bit more angle, and that'll be nailed. So to mark out the new bend that we want, basically, it's very, very simple. I'll just sit that over the top and then eyesight down from above, very roughly just work out how much more angle I want. It looked like it needed about 10 to 12 mil extra length and then a bit more angle. So I'll just rough that out with the Sharpie and draw a line on this new bend. And that should get me pretty close. I can cut that then. And then if it's needing a little bit of adjustment, I can use the linisher to then face this new cut in just a little bit of the right angle that we need to get it to. So now you can see I've cut this new bend and given a little bit of a linish to get the angle nice and accurate, but we'll sit this all together and you can see pretty spot on. So now that that's done, number 6 is going to tuck down and underneath, because if we were to then bring this one out and next to it to meet this port in the collector, we're going to start blocking access for the dump pipe of the turbo to come back and down, because the firewall will be here, back of the turbo's here, dump pipe's going to need space, so these need to be sort of tucked across. This will still give us clearance here, but if we brought another runner right next to it, we'll start running into clearance issues. So this one's going to have to tuck underneath and wrap into here. So this one's going to be a bit more complex, but that's the sort of forward thinking you need to have when you're doing manifold design as well. You have to think about, as well as like wastegate routing and space for wastegate piping and obviously everything else within the engine bay. So there's a lot that goes into it, but as long as you're aware of that, you can plan around it. So you can see now I have reinstalled the aluminium template around everything just to triple check the clearances. I've made this final runner for cylinder number 6 that will go here, and you can see it still has plenty of clearance to what will be the engine mount under this side. It's nice and tucked to the side here as well. So that runner's pulled in nicely alongside this, so there should be enough space to snake a dump pipe down through this corner of the engine bay, as opposed to say having the runner out here and like up above that one. It sort of restricts you with that whole extra 40 odd mil you are losing there. So very excited to get all these runners off now and start cleaning and welding. You can see that this one as well, cylinder number 3, fits in nicely. Plenty of space underneath and to the chassis rail here, so very happy with this design. And yeah, we'll get to welding. You can see here that I have now welded the collector. Very happy with this little rotated weld, and obviously the inside purged up all nicely, as you can kind of see there. Now with a quick little port on the inside of this, we have a nice smooth transition. It's one of those things that's it's not exactly 100% necessary. Like, it would have flowed perfectly fine without that, but it's just a nice little additional feature that I like to add on my manifolds. Just looks more professional. And yeah, I do the same for the wastegate outlet as well. So once that's welded and finished, I will hand port that flange so that it's all smooth. As a lot of you would be aware, this is my main form of income. This is my business, is making these turbo manifolds for customers. So there are certain things that I will not be divulging, and one of those is my welder settings and welding processes that go into doing these turbo manifolds. So that's just a professional secret that I'd like to keep to myself, that I've developed over many years. But you can see these are all welded, internally purged, nice and strong, ready to be assembled and turned into a manifold on the jig. One thing I forgot to mention earlier is that when you weld this material, it shrinks. So it's something that you have to factor in when you're making each runner, because obviously if you make it the exact length, it will then be too short by the time you go to assemble it. The other thing to remember is the amount of welds you do affects how much it shrinks. So one weld over a piece like this wouldn't really shrink that much. But if you have a complex runner that has like 4 or 5 welds in it, it'll shrink quite considerably, and you have to factor in a little bit of extra length. So I tend to try to make these longer rather than shorter for obvious reasons. And you can see here that this one hasn't shrunk as much as I thought it would have. It's still way too long here. So I probably could have taken maybe another 3 millimeters out of the length of one of these straights here to sort of pull that into place. But in this case, we can linish a bit out of this face on the head flange, which will sink this down and make this line up properly. So just needs a little bit of linishing. Obviously, that's the best outcome in this situation. If it was too short, you have to weld gaps. It can be done. It's just a bit more annoying, and it's a little bit more work when it comes to the welding. So this is just part of manifold making, and you just have to deal with it sometimes. Now, with a quick adjustment on that end on the linisher, you can see that we have nice little alignment there. So this one can get welded on now, and that was just to show you what can happen with the shrinkage of these. It's always very satisfying when you get to the very last runner. It just fits up perfectly. Very happy with that. So I will do this one last, as you want to have access to weld around the inside of every one of these runners as you go. If I was to weld, say, this one on and then put that one on, it'd make it very painful to get on the inside there. It's definitely possible, but it's just the process I like to do to make it as easy as possible. And then with this final one, to weld the inside, you need to use a small cup on the torch and get it on the inside of here, and just weld that last little bit. Obviously you have access to the outside most of the way around, but that last little section is always the tricky bit at the end of the manifold. So that's another thing that you need to factor in when you're making, or when you're designing a manifold as well, is to make sure that there's enough space to be able to slide a TIG torch inside here. So this one's especially good because so many of the runners split away towards the back here because the collector's up forwards. When the collector's in the center, it can get a lot more bunched up. So there's a lot of things that go into this. This manifold is a little uncommon in that the customer wants to run twin wastegates on a non-twin scroll setup, which usually when you have twin scroll rear housing, you have 2 halves to the rear housing and you need 2 wastegates to bleed the boost off the separate sides. But this just needs 2 wastegates for just extra boost control as requested by the customer. So I have these 3D printed TurboSmart 45mm wastegates that I use to mock up things. So obviously we've got the jig back together, the manifold's all welded. I can now work out where I'm going to merge my second wastegate in, where the rear one obviously is cast into the collector. Now this one will come out the front here. So I have this ruler sitting on here to mimic the top of the chassis rail, which is this edge of this jig assembly. And now I need to make this fit in this space roughly. So I'm going to have to merge a piece of pipe into the front of the collector here. So I'll probably use something like this and cut it and trim it until it fits in that front face. And then cut a hole out of here, weld this in, weld the wastegate flange on it, and then pour it all that perfectly smooth on the inside. After a bunch of linishing and sort of trimming this back, I've now got a nice shape to it. Now fits against the collector quite snugly. I'll be able to get a nice weld around that. I have made it fit up with the mock-up wastegate as well, so that will sit roughly in this area. You can see that it has clearance to the chassis rail now. This can point downwards and duck underneath the manifold for this wastegate pipe. The elbow for the turbo, which will be done by the fabricator on the customer's end of this, we'll have to cut the turbo up higher and weld a donut elbow onto it, but that's all pretty common these days. So yeah, very happy with that fit up. Now it's time to do a bunch of welding. I will cut the hole in this now. The wastegate outlets are now welded up. Very happy with how this came together. Some nice welds on this. Merges in nicely with a curve, as you want to encourage the gas to want to flow out here. That's why you don't weld just like a 90-degree notch in there. You want to have a bit of a bend so that the gas will want to flow through the wastegate. So you can see that this has plenty of clearance. Very happy with that. And same as this rear one, ready to go. Next up, we have to weld on the EGT probes. So I have these Speedflow stainless K-type EGT bungs. Very nice, they weld great. These will go on the top of each runner here, as the probe will go in, and then all the wiring will run behind the back of the head. So oftentimes you need to make sure that on the engine itself, sometimes the top of the head can have overhang or the cam covers sit out higher, so you need to make sure these have space. So usually I'll just use my Sharpie and sit it on there in the car on the engine. Luckily I have a JZ motor in the shop that I've checked, and there's no protrusions above this, so this should be fine to have them fairly close to the head. But sometimes you do need to check stuff like that, or there might be like castings hanging out and you have to put them on an angle to avoid it or whatnot. So this is something that you need to be aware of when you're doing this job, but this one's pretty straightforward, luckily. Another thing I have seen is some people will weld them like here and then in sort of weird positions, which I understand for clearance to things, but a very important part of EGTs is measuring an equal distance from the head on each of them. So you need to be very careful to mark out from the head face out to where it is, and it has to be the same on every runner. Because if I was to mount this, say, right here next to the head, and then the next one down here on this runner, the distance from the port to the sensor is completely different. So this one will read this one would read a lot higher with the heat coming directly out of the head, whereas this one has time for the temperature to cool down by the time it makes it to the sensor down here, which will give you an inaccurate reading. So you want to have these the same distance away from the head on every single one. It's very important. So I will just go along and mark, say, 30 to 35, say 30 mil. And then I'll go along and do that for every single one of these. And then once that line is drawn on every single one, I'll just eyesight the top of it and put a mark across there, and then center punch, drill, weld that, and then drill back through the center of that once it's welded to make sure that it's clear all the way through. And then we can port the manifold. And now we've come to the conclusion of this manifold. It's turned out super nice. Very happy with all the welding and setup and layout of everything. Ported and decked flat on this side. You can see all the runners are smoothed out nicely. This will flow very well. And that face has been machined flat on the large linisher over there. And now it's ready to pack up and send off. I hope you've enjoyed this video. I've really enjoyed making it. I'm very excited for the next video. Actually, I'm going to be taking a deep dive into some very serious, very intricate exhaust work on my car. So stick around, stay tuned, and I'll see you on the next one. Thanks again.